Selective laser sintering is an additive manufacturing technique that uses a laser as the power source to sinter powdered material, aiming the laser automatically at points in space defined by a 3D model, binding the material together to create a solid structure. It is similar to direct metal laser sintering. The two are instantiations of the same concept but differ in technical details. Selective laser melting uses a comparable concept, but in SLM the material is fully melted rather than sintered, allowing different properties. SLS is a relatively new technology that so far has mainly been used for rapid prototyping and for low-volume production of component parts. Production roles are expanding as the commercialization of AM technology improves. History: Selective laser sintering was developed and patented by Dr. Carl Deckard and academic advisor, Dr. Joe Beeman at the University of Texas at Austin in the mid-1980s, under sponsorship of DARPA. Deckard and Beeman were involved in the resulting startup company DTM, established to design and build the SLS machines. In 2001, 3D Systems, the biggest competitor of DTM and SLS technology, acquired DTM. The most recent patent regarding Deckard's SLS technology was issued January 28, 1997 and expired January 28, 2014. A similar process was patented without being commercialized by R.F. Householder in 1979. Technology: an additive manufacturing layer technology, SLS involves the use of a high-power laser to fuse small particles of plastic, metal, ceramic, or glass powders into a mass that has a desired three-dimensional shape. The laser selectively fuses powdered material by scanning cross-sections generated from a 3D digital description of the part on the surface of a powder bed. After each cross-section is scanned, the powder bed is lowered by one layer thickness, a new layer of material is applied on top, and the process is repeated until the part is completed. Because finished part density depends on peak laser power, rather than laser duration, a SLS machine typically uses a pulsed laser. The SLS machine preheats the bulk powder material in the powder bed somewhat below its melting point, to make it easier for the laser to raise the temperature of the selected regions the rest of the way to the melting point. Unlike some other additive manufacturing processes, such as stereolithography and fused deposition modeling, SLS does not require support structures due to the fact that the part being constructed is surrounded by unsintered powder at all times. This allows for the construction of previously impossible geometries. Materials and applications: some SLS machines use single-component powder, such as direct metal laser sintering. Powders are commonly produced by ball milling. However, most SLS machines use two-component powders, typically either coated powder or a powder mixture. In single-component powders, the laser melts only the outer surface of the particles, fusing the solid non-melted cores to each other and to the previous layer. Compared with other methods of additive manufacturing, SLS can produce parts from a relatively wide range of commercially available powder materials. These include polymers such as nylon or polystyrene, metals including steel, titanium, alloy mixtures, and composites and green sand. The physical process can be full melting, partial melting, or liquid phase sintering. Depending on the material, up to 100% density can be achieved with material properties comparable to those from conventional manufacturing methods. In many cases, large numbers of parts can be packed within the powder bed, allowing very high productivity. SLS technology is in wide use around the world due to its ability to easily make very complex geometries directly from digital CAD data. While it began as a way to build prototype parts early in the design cycle, it is increasingly being used in limited-run manufacturing to produce end-use parts. One less expected and rapidly growing application of SLS is its use in art. See also: 3D printing, desktop manufacturing, digital fabricator, direct digital manufacturing, fab lab, instant manufacturing, also known as direct manufacturing, or on-demand manufacturing, rapid manufacturing, rapid prototyping, RepRap project, solid freeform fabrication, von Neumann Universal Constructor. References. External links: DMLS, a Euro development history and state of the ART, selective laser sintering, Birth of an industry.